Hello everyone, welcome back to my channel InfoSec Lab. Today we are going to talk about another topic in web application security, which is XSS. Now this is a must-know topic for any of you who wants to get into the web application security. So what does XSS stand for? XSS stands for cross-site scripting, which is a well-known vulnerability in modern web applications. This is where you get to know what XSS is and how attackers exploit web applications. Introduction. Cross-site scripting remains one of the most common vulnerabilities that threaten web applications to this day. XSS attacks rely on injecting a malicious script into a benign website to run on a user's browser. In other words, XSS attacks exploit the user's trust in the vulnerable web application, hence the damage. One of the earliest XSS vulnerabilities was recognized in 1999 and led to a CERT advisory CA 2002. Over the past decades, various robust web application practices have become part of the modern web application frameworks, protecting against many XSS vulnerabilities by default. On the other hand, motives and certifications of the attacks have also grown. With the rise of the web applications, it is no longer an exaggeration that a few XSS vulnerabilities are discovered and exploited every month. In the OWASP Top 10, XSS was ranked 7th in the 2017. In 2021's report, XSS was grouped with other injection attacks and together are ranked 3rd. In this room, we explore XSS in depth to help you discover, exploit, and patch XSS vulnerabilities. There are some prerequisites for the room. It is expected to have basic knowledge of HTTP and how websites work. If you don't have any of this knowledge, we recommend completing How the Web Works module first. If you are unfamiliar with XSS, we highly recommend completing Intro to Cross-Site Scripting room to gain a more in-depth understanding of XSS, particularly reflected XSS, store XSS, DOM-based XSS, and how to protect modern web applications against XSS. We provide code snippets using different web frameworks to understand better the expectations of and securing against XSS vulnerabilities. We don't focus on the code itself. We focus on the reasoning behind the vulnerability and some solutions. The purpose is to help us better understand why XSS came to exist and what makes it exploitable. Alright, let's get started. Terminology and types. As already stated, XSS is a vulnerability that allows an attacker to inject malicious scripts into a web page viewed by another user. Consequently, they bypass the same origin policy, or SOP. SOP is a security mechanism implemented in modern web browsers to prevent a malicious script on a web page from obtaining access to sensitive information on another page. SOP defines origin based on the protocol, hostname, and port. Consequently, a malicious ad can access data or manipulate the page or its functionalities on another origin, such as online shop or bank page. XSS notches SOP, and it is executing for the same origin. JavaScript for the XSS. Some basic knowledge of JavaScript is pivotal for understanding XSS exploits and adapting to your needs. Knowing that XSS is a client-side attack that takes place on the target's web browsers, we should try on attack on browsers similar to that of the target. It is worth noting that the different browser process certain code snippets differently. In other words, one exploit code may work against Google Chrome, but not against Mozilla Firefox or Safari. Suppose you want to experiment with some JavaScript code in the browser. In that case, you need to open the console file under the Web Developer Tools in Firefox, Developer Tools on Google Chrome, and Web Inspector on Safari. Alternatively, you can respectively use the shortcuts. And because we're using the Firefox from the virtual machines, it's going to be this one, Ctrl-Shift-K, the shortcut. Let's review and try some essential JavaScript functions. Alert. You can use the alert function to display JavaScript alert in a web browser. Try alert1 or alert XSS with either the single quotation mark or double quotation mark to display an alert box with the number 1 or the text XSS. Console log. Similarly, you can display a value in the browser's JavaScript console using the console.log. Try the following 2 examples in the console log. Console log 1 and then console log test text to display a number or a text string. Encoding. The JavaScript function BTOA string encodes a string of binary data to create a basis for encoding ASCII string. This is useful to remove white space and special characters or encode other alphabets. The reverse function is ATOB, basis for string. Alright, so let's try experimenting. Furthermore, you can experiment with displaying values such as document.cookie. Okay. Let's try that. We have inspect right here. Let's see if we can make it bigger for you. Yes, I can make it bigger. So first of all, we're going to try alert 1. We see there's a box right here. Or we can say alert with some text. Now make sure that you have this quotation mark, either the single quotation mark or the double quotation mark, it doesn't matter. But if it's a string, we have to enclose that in a quotation mark. So hello from info. See, shows right here. Okay, and then we can try console.log right here. Oops. Now the difference is when you use the alert function, there will be a box display on the web browsers where the console log will display on this console only. As you can see right here, there's no alert box popping up from the web browser. We can try another one. Now this time is console log hello from info lab. As you can see right here, it prints the text into this console. And what else do we have? We have console. Oh, the encoding. So now, encoding console.log will have. Now let's try it. So we're going to basically encode the string hello from info lab. And what you're gonna see right here is a random string. Well, it's not a random string. It's a string with random characters. So when you use this BTOA function, it encodes the whole string right here into the base64 format, which turns out to be these values right here. And as you can see right here from the string, there's no space, even though in the original string, we have 1 space, 2 spaces right here. But once the ASCII string is encoded into base64, then there's going to be no string. And if we copy this one, the base64 encoded string, and then use this function, we're going to get the exact same values, which is hello from info lab. Now we can combine these two to have an alert on this box by alert, and we can paste this one. You can see hello from info lab. Now instead of printing the values or the text in the console log, it brings the value in an alert box on the web browsers. Moving on. Types of XSS. To recap, the intro cross-site scripting room, there are 3 main types. Reflected XSS. This attack relies on the user control input reflected to the user. For instance, if you search for a particular term and the resulting page displays the term you search for, reflected, the attacker would try to embed a malicious script within the searcher. Store XSS. This attack relies on the user input stored in the website's database. For example, if a user can write product reviews that are saved in the database, which is stored, and being displayed to other users, the attacker will try to insert a malicious script in their review so that it gets executed in the browsers of the other users. DOM-based XSS. This attack exploits vulnerabilities within the document object model, which is known as DOM, to manipulate existing page elements without needing to be reflected or stored on server. This vulnerability is the least common among the 3. Answer the questions. Which XSS vulnerability relies on saving a malicious script? That's store XSS. Which prevalent XSS vulnerability executes within the browser session without being saved? That's reflected XSS. And what does DOM stand for? Document Object Model. Causes and implications. Cross-site scripting is a web security vulnerability that allows an attacker to inject malicious scripts into a web page viewed by other users. As a result, the unsuspecting users end up running an unauthorized script in their browsers, although the website they are visiting is trusted to begin with. Therefore, XSS can be a severe threat because it exploits user trust in the site. What makes XSS possible? There are many reasons why XSS vulnerabilities are still found in web applications. Here's a few of them. Insufficient input validations and sanitization. Web applications accept user data, provide forms, and use this data in the dynamic generations of HTML pages. Consequently, Malicious scripts can be embedded as a part of the legitimate input and will eventually be executed by the browsers unless adequately sanitized. The lookup output encoding. The user can use various characters to alter how a web browser processes and displays a web page. For the HTML part, it is critical to properly encode characters such as the smaller sign, greater sign, single quotation mark, double quotation mark, and ampersand into their respective HTML encoding. For JavaScript, special attention should be given to Xgap, quotation mark, which is both single and double, and backslash. Failing to encode user-supply data correctly is the leading cause of XSS vulnerabilities. Improper use of security header. Various security headers can help mitigate XSS vulnerability. For example, Content Security Policy, or CSP, mitigates XSS risk by defining which sources are trusted for executable script. A misconfigured CSP, such as overly permissive policies, or the improper use of the unsafe inline or unsafe equal directives, that can make it easier for attackers to execute their XSS payloads. Framework and language vulnerabilities. Some web frameworks did not provide security mechanism against XSS. Others have unpatched XSS vulnerability. Modern web framework automatically escape XSS by design and promptly patch any discovered vulnerability. Third-party libraries. Integrating third-party libraries into web applications can introduce XSS vulnerabilities, even if the core application is not vulnerable. Implications of XSS. There are many implications of XSS. Below is a list of them. Session hijacking. As XSS can be used to steal session cookie, attacker can take over the session and impersonate the victim if successful. Phishing and credential theft. Phishing and credential theft. Leveraging XSS, attackers can present a fake login prompt to user. In one recent case, the browser's page was partially hidden by a dialog box requesting user to connect to their cryptocurrency wallets. Social engineering. Using XSS, an attacker can create a legitimate looking pop-up or alert within the trusted website. This can trick users into clicking malicious links or visiting malicious websites. Content manipulations and defacement. In addition to phishing and social engineering, an attacker might use the XSS to change the website for other purposes, such as inflicting damage on the company's reputation. Data exfiltration. XSS can access and exfiltrate any information displayed on the user's browser. This includes sensitive information such as personal data and financial information. Malware installation. A sophisticated attacker can use XSS to spread malware. In particular, it can deliver drive-by download attacks on the vulnerable websites. Based on the leading cause of XSS vulnerabilities, what operations should be performed on user input? That's validation and sanitization. To prevent XSS vulnerabilities, what operations should be performed on the data before it is output to the users? It should be encoded. Reflected XSS. Reflected XSS is a type of vulnerability where a malicious script is reflected on the user's browser, often via a corrupted URL or form submission. Consider a search query containing script alert document.cookie script. Many users wouldn't be suspicious about such URL, even if they look it up closely. If processed by a vulnerable website, it will be executed within the context of the user's browser. In this innocuous example, it displays the cookie in the alert box. Obviously, an attacker wants to achieve more than just displaying the cookie as an alert user. However, for such an attack to be possible, we need a vulnerable application. Vulnerable web application. One simple reflected XSS vulnerability is when the user searches for some term, and the searching is included verbatim in the result page. This simple scenario provides an easy target for the attacker to exploit. Although discovering such vulnerabilities is not always easy, fixing them is straightforward. User input such as script alert XSS script should be sanitized or HTML encoded to a string like this. So in the following subsections, we provide examples of vulnerable code in the following languages and frameworks: PHP, JavaScript, Python, and C#. For the PHP vulnerable code, it looks something like this. You search for in a search query. You are unfamiliar with PHP. The get right here is a PHP array containing values from the URL query string. Furthermore, this get refers to the query string parameter q. For example, in HTTP shop TryHackMe search PHP q equals table, this get has the value of table. So if this q has a value of TryHackMe, then this get has the values of TryHackMe. As you may have guessed, the vulnerability is caused by the search value displayed on the result page without sanitization. Therefore, an attacker can add malicious script to the URL, knowing it would be executed. For example, as a proof of concept, the following URL can be tested. Sharp TryHackMe search, and then instead of putting a regular values right here, we try a malicious script. And if the site is vulnerable, an alert box will appear displaying the user's cookie. So how to fix it? We're going to get the query value from the URL right here. And before doing anything with this query, we have to sanitize it. The way we do this is to use the PHP function HTML special characters, which converts the special characters to HTML entities. The special characters like greater or smaller size, ampersand, quotation marks are replaced by default to prevent scripts in the input from executing. JavaScript or Node.js application. The following Node.js is vulnerable to reflect XSS. Try to find a vulnerable part and think of a solution. So this is a search one function, and similar to the above PHP function, the queue here will get the values from the URL. And as you can see right here, without any sanitizations or validation, we directly apply an operation or a function to the search term or the query values, which is right here. So this is going to be the issue. Okay, so because a value is taken from the URL and inserted into response HTML without sanitization or escaping, it is easy to append a malicious query. As a proof of concept, we can test the following this one. Similar to the above example, instead of putting the table as a regular user, we can try a malicious code. Because this snippet doesn't have any validations or sanitization process, it is vulnerable to XSS attack. And here's a fixed version of the code. As you can see right here, we acquire the values of the query, and then we have to sanitize this value first before actually render that onto the HTML file. And in Node.js application, we use the function sanitize HTML from the sanitize HTML library. This function removes unsafe elements and attributes, which includes removing script tags among other elements that could be used for malicious purposes. Again, you can read about this function right here. Another approach would be using the special function escape HTML function instead of sanitize HTML function. As the name indicates, the escape HTML function aims to escape characters such as greater sign, smaller sign, ampersand, quotation marks. You can check it here. Python Flask. Similar concept. It's just different frameworks, different ways to acquire the query. Here we have a query which we get from the URL, and in this vulnerable code, without doing any sanitizations and validation, we directly bring the query to the web application, which is vulnerable to XSS attack. To fix that, we have to sanitize and validate. In Python, we use the html.escape function in Flask, which is an alliance of markup safe.escape function. They both come from the works search library and serve the same purposes, escaping unsafe characters in strings. This function converts characters like these into HTML escape entities, disarming any malicious code user has inserted. Similarly, C# application or ASAP.NET. This is a vulnerable code. We don't see any sanitizations and validation. To fix it, we use http utility.html encode function, which converts various characters into their respective HTML entity encoding. Which one of the following characters do you expect to be encoded? Is the ampersand side. Which one of the following characters do you expect to be encoded? That's the smaller sign. Which function can be used in JavaScript to replace unsafe special characters within the HTML escape HTML? Oh no. Sanitize HTML. Which function do we use in PHP to replace the HTML special characters? I forgot. Let's check it out. In PHP, we use HTML special characters. Vulnerable web application 1. Now we can start the machine, and in this attached VM machine, it runs the vulnerable version of a copy party. The discover reflected XSS vulnerability has the ID CVE 2023 38501. So let's take a look at it. And its exploit is published here. So the exploit code is going to be this one. Now this is a URL encoded version of the exploit. So what we can do is actually from here go to server chef and see what it actually is. In the meantime, let's take a look at this one. The description: copy party is a file server software. Prior to version 1.8.7, the application contains a reflected cross-site scripting via URL parameter, and this is going to be the parameter that we're going to exploit. The worst case outcome is being able to move or delete existing files on the server or upload new files using the account of the person who clicks the malicious link. It is recommended to change the password of one's copy party accounts, unless one have inspected one's logs and found a trace of attack. Okay, so let's take a look at this one. The machine has been started, and here's the URL of the vulnerable machine. Let's visit. And let's see what the exploit is. This is going to be the parameter, which will append to the end of the URL. Let's try that. How this strange unit login admin panel dumpstat has it been successfully exploited? I'm not sure. The attached machine has a vulnerable server running at port 3923. You can reach the vulnerable server here. Okay, what type of vulnerability it is? So it's going to be reflected XSS. Ignore it. And use the above exploit against the attached machine. What do you see in the second line after go to? Let's try again. Oh, it's because this one is not URL encoded. So let's try the URL encoded version. Okay, we have successfully exploited this application. So the go-to link is this path right here. $H, the £, and $C. Moving on, Store XSS. Store XSS or persistent XSS is a web application security vulnerability that occurs when the application stores user input and later embeds in its web page served to other users without proper sanitization or escaping. Examples include web forum posts, product reviews, user comments, and other data stores. In other words, Store XSS takes place when the user input is saved in a data store and later included in the web pages served to other users without adequate escaping. Store XSS begins with the attacker injecting a malicious script into the input field of a vulnerable application. The vulnerability might lie in how the application processes the data in the comment box, forum post, or profile information section. When other user accesses stored content, the injected malicious script executes within their browsers. The script can perform a wide range of actions, from stealing session cookies to performing actions on behalf of the user without their consent. The vulnerable web application. There are many reasons for a web application to be vulnerable to Store XSS. Some of the best practices to prevent Store XSS vulnerabilities are: validate and sanitize input, define clear rules, and enforce strict validations on all user-supplied data. For instance, only alphanumeric characters can be used in a username, and only integers can be allowed for each fields. User output escaping. When displaying user-supplied input within an HTML context, encode all HTML-specific characters, such as the greater sign, smaller size, and ampersand. Apply context-specific encoding. For instance, within a JavaScript context, we must use JavaScript encoding wherever we insert data within a JavaScript code. On the other hand, data placed in URLs must use relevant URL encoding techniques like percent encoding. The purpose is to ensure that URL remains valid while preventing script injection. Practice defense in that. Don't rely on a single layer of defense. Use server-side validation instead of solely relying on client-side validation. So in the following examples, we'll list vulnerable code snippets in various languages. This exercise should be easy this time as the solution resembles the solution implemented earlier. So for the PHP vulnerable code, it would look like this. Read a comment from the user and save it into the comment variable, which is this one. Add a comment to the column comment in the table comments. So this is the code right here. And later it iterates over all the rows in the column comment and displays them on the screen. So this is the part where we retrieve all the comments from the comment table and display them on the web page. So this is a vulnerable version. We're concerned with the store XSS as the SQL injection outside the scope of this room. Oh yeah, this is vulnerable to SQL injection too, yes. The main issue is that the comment is saved and later displayed amongst other comments without sanitization. Once we have retrieved all the comments from the comment table, without sanitization or validation, we just directly display these comments onto the web page. And when a comment is malicious, then it would, when displayed on the web page, it would actually execute the script. So here's a fixed version of the code. After you retrieve the comments, you have to sanitize it first. And you store it in the sanitized comment right here. And the function we use is again HTML special characters. Alright, so like I said, before we display on the screen, we pass it through the HTML special characters function to ensure that all special characters are converted into HTML entities. Consequently, an attempt for store XSS won't make it to the end user's browser. This is outside of scope. However, if you're curious about SQL injection vulnerability, this is a little bit using of the MySQL real escape string. So this function HTML special characters is used to sanitize comments retrieved from the table, and this function is used to escape special characters in the input strings before you actually put the comment into the table. JavaScript or Node.js application. The following JavaScript code reads the comment received from a user that was saved in a database. We assume that the comments already have been populated from the database. Discover what makes it vulnerable, store XSS, and how to solve it. So this is an HTML element, UL, an order list. And for every comment in the comments arrays, we display the comment. So the problem is going to be right here. We just directly display the comment without any sanitizations, which is a no-no. So the main issue here is that it reads the user input and save it in the comment from the comments array and display it as a part of HTML code. Consequently, when another user uses the user's comment as an HTML, the browser will execute any script injected into that. And the fixed version, again, we have to use a sanitized HTML function right here. Moving on to Python. This is a vulnerable code from Python. As you can see right here, this function lays a foundation for the XSS. Why? Because it intakes the user input and without any validations and sanitization, it just directly stores the comment into the database. Hence, when retrieving all the comments from the database over here and display that on the HTML page, because the inputs are not sanitized when they're saved into the table and before being rendered to the web page, they're vulnerable to XSS. Right? Here's a fixed version of that one. As a best practice, we have to sanitize it before saving that to the database. Also, but let's say that for some reason we forget to do this, we can actually do another one right here. After retrieving the comments from the database, we have to sanitize all the comments, and after that we can display that into the HTML file. And in Python, we use the escape function to ensure that any special characters are replaced with HTML entities. C#.NET. Same thing, similar concept. We are looking for the command. This is saving the user comment into the database. This is displaying comments. Reader new SQL command. And over here we can see that we just read whatever comments retrieved from the database and display on the web page without any sanitization. So to fix it, we have to have another piece of code or another line of code that sanitizes the array before displaying that on the web page. Well, the fixed version is supposed to be this one, sanitize comments, right here. And the function we use is HTTP utility, not HTML encode with the comment right here. Same concept. Answer the questions below. What is the name of the JavaScript function we use to sanitize user input before saving it? JavaScript function is what was it? This one sanitize HTML. Which method do we call in ASAP.NET C# to sanitize user input? Is HTTP utility this one? HTTP utility.html encode. Practice. Vulnerable web application 2. The attached VM runs the vulnerable project hospital management system. The project was uploaded a few years ago and was never updated since then. It is fully functional. Unfortunately, a .xss vulnerability was discovered and tagged as CVE 2021-38757, and an exploit was published, but the application has not been patched to the time of writing. To exploit the vulnerability, the attacker only needs to click on the content, fill in the name, email, phone number, and submit the payloads in the message field. Something such as script alert simple XSS will work. Any messages sent via the contact page appears on the receptionist when they log in. To log in the receptionist, we use the following credentials. Okay, so let's try that. It's going to be the same IP address, right? Yes. No. HTTP. Okay, I guess we have to restart the machine. Let's do it. Terminate this one and start this one. Okay, while we wait for the machine to start, let's continue our readings. The vulnerability lies in the content.php. Although the code works well, it is not secure. As we can see in the listing below, the user's submitted message is saved unsanitized in the database table. Here's the name variable, email, contact. These are the information that we got from the user input. And then without any sanitization, we directly save them into the database in the name, email, contact, and messages columns. Answer the question, what type of vulnerability is it? Is store XSS. Go to the contact page, submit the following message, script document.cookie. Next, login with the login as the receptionist. What is the name of the key from the display key pair values? Okay, so this is the payload we're going to use. Document.cookie. Okay. And here's the vulnerable target. Contact page. Oh, we gotta copy paste that. It's easier. Admin 123. Okay, now we have successfully sent a message from the front end. Let's say I am an admin. I want to log in as a receptionist, so admin. And the password is admin123. Admin password admin123. Okay, so now we get the user's cookie. So the key is going to be a PHP session ID. Right. Next, DOM-based XSS. If you check any updated security advisories, it is easy to find new reflected installed XSS vulnerabilities discovered monthly. However, the same is not true for the DOM-based XSS, which is getting scarce nowadays. The reason is that DOM-based XSS is completely browser-based and does not need to go through server and back to the client. At one point, a proof of concept example of DOM-based XSS could be created using a static HTML page. However, with the improved inherent security of web browsers, DOM-based XSS has become extremely difficult. Before we dive into DOM-based XSS, let's review what Document Object Model, or DOM, is. The DOM is a programming interface representing a web document as a tree. The DOM makes it possible to programmatically access and manipulate the different parts of the web application using JavaScript. So let's consider this practical example. Consider you have the HTML code on the example.com. Is it a valid one? I guess not. We open the web browser tools using Firefox and we take a look at the source code right here. The DOM tree shows that below in the following sublist. So we have document, yeah, we have the doc type HTML, and then we have HTML, we have head, title, meta, style right here. HTML head, title, meta, and then we have style, structure. So this is a DOM tree. Tree start at document node, branches into doc type and HTML. HTML node branches into head body, and the head has a title, a few meta tags, and a style. In this example, the body has a single div that branches into h1 and 2 paragraph elements. This is a concise page. For more practical pages will have tens or hundreds of branches. Yeah, we can view the DOM tree using the web browser built-in web browsers tool. For example, Ctrl+Shift+I on Firefox. Alternatively, we can access the JavaScript console as mentioned in task 2. Using JavaScript, you can manipulate the DOM tree. So for example, you can create a new element using document.createElement and add a child to any element using element append. This is a div and this is a paragraph. We create this one, we create another paragraph element, and then we append that. So this code right here, we append a paragraph element into the div element. Vulnerable web applications. DOM-based XSS vulnerabilities takes place within the browser. They don't need to go to the server and return to the client's web browser. In other words, the attacker will try to exploit this situation by injecting a malicious script, for example, into the URL, and it will be executed on the client side without any role for the server. We will present an elementary and minimal static site without relying on the backend code to demonstrate this concept. Do we need a start a web application? No, we don't. No, we're good. Okay, we start right here. Vulnerable static sites. Let's consider the following basic example. It's too simple that it's unrealistic. However, it's enough to demonstrate the DOM-based XSS. So we have a simple web page right here where it says hello and the name of the users. The page above expects a user to provide the name after the name parameter right here. The user enters the web page after the name using a URL. Greeting word as expected display the hello web tester right here. So here's the URL right here. This is the original URL, and then this is the parameter name equals web tester. The greeting word as expected and display hello web tester over here. It displays on web page. And finally, the DOM structure on the right is left intact. The body has three direct children right here. The user might try to inject a malicious script in the screen below. We see the following. User add the script right here instead of only web tester. The script was executed and an alert box was displayed. The most importantly, we can see how the DOM tree got a new element body and has 4 children now. Previously, when we input a regular name, which is web tester, we have 3 children, one, the div, the script, and the hello tester. But now, because we inject this as one, there is going to be another alert box popping up. Now the HTML page or the DOM tree has 4 elements, which is this part right here. This basic example illustrates a couple of things. The server has no direct role in the DOM-based vulnerability. In this demonstration, everything took place in the client's browser without using a backend. So the DOM was insecurely modified using document.write. So how do we fix it? The code is, again, to escape the user input to prevent XSS attack. After getting the username from the parameter, we have to escape any special characters using this special function encode URI component. And then once we escape all special characters, we can actually display that onto the application. That's one way to fix it. Another way is to avoid adding user input directly with the document.write. After implementing the fix, we can see that if we try a malicious script, it does not work anymore. That's it for the DOM-based XSS. It's pretty similar to the reflected XSS in the sense that when user provide malicious input without any sanitization, the web page will directly execute the script Answer the questions. Download XSS is reflected by the server. No. Download XSS happens only on the client side. Yes. Which JavaScript method was used to escape the user input? Encode URI component. Context and invasion. Context. The injected payload will most likely find its way within one of the following: between the HTML tags, within the HTML tags, inside JavaScript. When XSS happens between the HTML tags, the attacker can run the script alert document.cookie. However, when the injection is within the HTML tag, we need to end the HTML tag to give the script a turn to load. Consequently, we might adapt our payload to something like this, with a greater sign and then the regular script that we inject. We might need to terminate the script to run the injected one if we can inject our XSS within an existing JavaScript. For instance, we can start with script, with ending the script, to end the script and continue from there. If your code is within a JavaScript string, you can close the string using a quotation mark, complete the command with a semicolon, execute your command, and comment out the rest of the line with the double slashes. You can try something like this. This example should give you some ideas how to escape the context you start from. Generally speaking, being aware of the context where your XSS payload is executing is very important for successful execution of the payload. Evasion. Various repositories can be consulted to build your custom XSS payload. This gives you plenty of room for experimentation. One shortlist is XSS payload list. However, sometimes there are filters blocking XSS payloads. If there's a limitation based on the payload length, then this tiny XSS payload can be a great starting point to bypass. So this is another one, tiny XSS payloads. If XSS payloads are blocked based on a specific block list, there are various tricks for evasion. For instance, a horizontal tab, a new line, or a carriage return can break up the payload and evade the detection engines. Here's the horizontal tab, is 9 in hexadecimal. New line is A, capital A, and carriage return is capital D. Consequently, based on the XSS filter evasion cheat sheet, we can break up the upload, or we can break up the payload, something like this. This is the original one in various ways. This is one way. Here we injected a tab between the JavaScript. This is a tab, this is a new line, and this is the carriage return. There are hundreds of evasion techniques. The choice will depend on the target security and require trial and error before achieving a successful outcome. So which character does this hexadecimal represent? That's tab. Conclusion. The purpose of this room is to give you a more in-depth understanding of the underlying workings of XSS scripts. We cover the causes and many remedies for XSS scripting. Understanding what's happening behind the scenes will give you an edge in exploring existing exploits and adapting them to your needs. Answer the question. This room used version of static site to demonstrate one of the XSS vulnerabilities. What type is it? That's numbase. And we completed the room. Hope you enjoyed this room, and if you have any questions, feel free to reach out to me. Have a good day. Bye.